Have you noticed that there's a bunch of videos on the last couple of sections? Because I'm putting all the videos from 103, 120 a.m. and 120 p.m. on the thing because y'all are all going over the same stuff right now. So if you watch all those videos and you attend class, you should be okay for the test because you're getting like triple whammy. You're getting like 3 classes for 1. So just telling you for the one person that watches the videos. All right. Getting a green light at a busy intersection at least 1 to 4 times a day, given that the light is direction, blah, blah, blah. Basically, what this one is saying is really simple if you cut all the bull crap out. Probability of a green light is equal to 4 out of 10. Therefore, the probability of not a green light, which is got an X over it or a line over it, whatever you want to do, is equal to what?
6 out of 10.
6 out of 10. Now you can reduce if you want to. This is one of the most missed questions on the test. Can somebody tell me why this is the most missed question?
Because it's asking for the complement.
It's asking for the complement, but you can't tell it because of the way the question's worded.
From where did you
It's asking for the complement. And what is the complement?
Not green.
What makes up the what?
The other half.
The whole.
Oh, yeah.
Yeah, you didn't listen that day.
I probably wasn't here that day,
You
actually.
probably wrong. Anyway, so what if P of G is 2/10?
Not green.
P of G is 2/10. Then what's P of not G? 8/10. And I'm glad you asked this question because, like I said, when I put that on the test, some people miss it because it's written, take this out and put 0.4. Well, what's the complement of 0.4? 0.6. And they'll miss it because you'll do this question and it's got 4/10 or it's got 3/4. Here, let's do 3/4. 0.75. What if it's 0.75? 0.25 is not green. Okay? So, however you want to word it, I don't know. Getting a green light at a busy intersection times a day, given that the light in your direction is green 4/10 of the time, the probability is 0.4. They're not asking for the complement, they're asking just for 0.4, which is 4/10. 0.4, I guess that's what they're asking for. One question is worded like this, is asking for the complement. I thought that was what this one was asking for. God, this one's even easier than the complement.
Yeah, I was about to say, that one seemed really easy.
It's asking for the complement. I thought it was asking for the complement. So that'd be 0.6.
Oh.
Now, where do you... Okay, I have no idea what it's asking for now.
Yeah, that's what I was about to say, is how do you know what it's asking for if it doesn't, like, say?
Yeah, this question, it's not a good question, and plus I've got it wrong. I have no idea what the answer is unless they want 6/10. 6/10, what's 6/10?
It's just
3/5. So either they want 6 out of 10. No, that's not right.
Kept doing this way.
Hold on a second. What did somebody do right quick? What's 2 out of 5? 2 out of 5 is 0.4, is it not? Who is that? Oh, good morning.
yeah, it's 0.4.
Okay, then that question's wrong. I have no idea what they're asking. You were right to send this question, Miss Anya Sador, because it's not correct. In fact, let's look. To show you that I'm not making it up, let's go up to help me solve this. View an example.
Yeah.
Let me get rid of everything. All right, 7/10 of the time. So the answer is 3/10 or 0.3. That's the answer. So let's see what they get. Okay, am I right? Yeah. I don't know what they're doing here because it doesn't ask for n is equal to 2. Where did they get n is equal to 2?
They're squaring.
Confusing.
Okay, maybe I don't understand the question. What?
Because of 2 times through the intersection. That's 2 times. Is
Okay,
what
where
they
does it
want.
say 2 times?
Yeah, they say given that.
Oh, I'm sorry. Okay, I'm totally.
Like this
Okay,
one now
4
is
times.
4
All
times.
right. Okay, let me reread the question. Getting a green light at a busy intersection at least once in 4 times. Okay, there it is. At least once in 4 times. At least once in 4 times. So that's 1 out of 4. Okay, but through the intersection, given that the light is in your direction, that's where they're getting. Okay, that's where they're getting the exponent from. Okay,
That's first part.
this is not a test question. Okay, the way that one little piece in there is not a test question. So you have to do the complement to the to the 4th power. That's what they're doing. So you got 0.7, so 0.3, and then you're going to raise that 0.3 in this case to the 2nd power. That's what they're doing right there. So I've never seen this question before. So take what's the complement of 4/10? 0.6. So that's going to be 1 minus 0.6 raised to the 4th power. So somebody do that. 1 minus 0.6 raised to the 4th power. So somebody do that in your calculator, please.
Probability was 4%.
Hold on, I gotta shut off this God blessed phone.
It's like what fills the hole.
It's fixed.
Okay, now y'all shouldn't be asking about the complement, please. I mean, I have been teaching the complement for I don't know how long. You got 2 or 3 videos on the complement. Y'all should know what the complement of 4/10 is. It's 6/10. And y'all should know that. I don't know who that was. I'm sorry. I'm aggravated because God bless the phone went off. I'm sorry. Oh, great. Now my son. Okay, hold on just a second.
Fine, sir. Fine. That first part is hard for me. The first one.
Okay, I'm sorry. So somebody take 0.6 and raise it to the 4th power.
0.0102.
0.01 what?
0.01024.
0.024. Has everybody got that?
Yes.
So somebody subtract 0.01024, and what do you get?
No, I have subtracted it already. That's the final.
Oh, that's the final answer.
Let me get a calculator.
I didn't know.
Okay, I'm asking, what is 0.6 raised to the 4th power?
0.1296.
Hold on.
1, 2, 3, 4. Okay, 12.
Okay, give it to me again. Point what?
1296.
1296. Now, what is 1 minus 13 cents? 87 cents. So that's where they're getting it. Okay, so what's 1 minus 0.1296?
87.
0.8704.
Yes.
Oh, yes.
Okay, I apologize for messing this problem up. I didn't see this right here. And that's the difference between the two. There's another question that says getting a green light is 4/10 of the time. What is the probability of not getting a green light? That is usually the question I put on the test. I've never seen this question before. So they must have threw this question in on MyLabs Plus in the last semester, in the last few months, because I haven't seen it. So thank you, Ms. Ansador, for sending it because like I said, I've never seen that question before. So I guess you could say 1 minus the complement raised to the n power. 1 minus the complement raised to the n power. And n is going to be whatever they say right there. Okay? Okay, question. We'll do one more just so you'll have 2 of them. So I'm going to go right here. And there's that one, so y'all do that one. 6 times.
Is it always hot? I mean, let them do it.
It's like the last one was 6 and the other one was 4. It's supposed to be 7, 3. Could be 7.
7 because it's the complement, 6 because it's in the middle of the question. 6 times.
Oh, okay, yeah.
Would it be 7 or 0.7?
0.7.
Yeah. So. Did you get -0.8?
I got 8.
Okay.
But I don't know.
Mine had
I'm sorry, I've got an issue at my son's school. I'm trying to take care of it till I get out of class. Hold on just a second. Typical 12-year-old boy
No.
means he's in trouble. He's going to be in trouble after school, that is.
Yeah, worse than what my brother did. He was really stupid. He got expelled.
Well, this one won't get expelled. He won't be able to sit for a week.
I think I would start this. They won't like this.
No. No. Where does that point she's coming here?
Okay, I'm sorry. Okay, so playing on his freaking phone.
Yeah,
Yes, the complement. So, like, do you see where it says 3/10? It would be 7/10, which would be 0.7 because that's how much is left from.
The 0.7.
Yeah, that's the complement.
0.7.
Okay, green light at a busy intersection at least 6, so n is equal to 6. Okay, given that your light probability of green is equal to 3/10, therefore, the probability of not green is equal to what? 7/10. Now you can use 3/10 and 7/10, or you can use 0.3 and what? 0.7. I really don't care which one you use, because it's going to give you the same answer. So now we put it in the formula I just gave you, which is 1 minus what? 0.7 raised
Yes.
to the what?
6.
To the 6th power. And somebody give me 0.7 raised to the 6th power, please.
0.1176.
And then 1 minus 12 cent is 82 cent, but what does it come out to be?
I got 0.88.
88, sorry. 0.88 what? 2.4?
Yeah.
Yes.
So 0.882. 0.882.
Because I kept doing times this and that. I don't want to press it.
So I did it. I just did it.
Okay? Who's got a question?
Ah, okay.
And then you would just
That is here.
Yep.
Okay.
And then you would just click
Okay, fine. Thank you. But how that 710 came in is where what I don't know still.
You would just
No, probability not green. 7/10.
yeah. So because the probability of the green light is 3/10, you just have to find out like what is left over. So like 3 minus 10 would be 7. So that's how you know how much is
3 minus 10. Ah,
Yeah.
okay, okay.
I'm a little bit confused. Did I not cover complement?
yeah.
Okay, I don't understand. I've covered complement, and it's on the videos, and people, you're not the only one. My 120 class, that like I've never covered it. Last night, I went off on them, and I'm like, have I missed something? Okay, I'll go over it one more time. What's the complement of yes?
No.
So you
What's
always
the complement of true?
this.
Yeah, it would just be what's left over.
False. Okay, is everybody listening?
Yes.
What's the complement of guilty?
Not guilty.
Not guilty. All right, now those are words. Okay, but the whole point is, this is a whole. That is a whole. This is a whole. You either have two sides. There's two sides to a coin. There's two sides to a seesaw. Okay? So a coin, I can't draw a coin because it's just a circle. But how many sides of a seesaw are there? Two. The whole seesaw is made up of two sides. So everything in binary land, binary means two, is made up of two things. So if I give you 200 people that work at a company, and I say 150 are sick, then how many are not sick? Because two sides of a what? Two sides of a seesaw. If 150 are on one side and there's 200 in all, then how many are on the other side?
I see that answer.
And I told y'all, same as I told the math 120, I told y'all it can be either with a quantity or it can be with a percentage or a what? Decimal. So let's say I go, there's a 60% chance of rain today. So what's the opposite? What's the other that makes up the not rain? Okay? Rain. R-A-I-N. And then an X through it. What would it be? 40%. With a percent, there's two sides. With a seesaw, there's two sides. One more. If I give you a seesaw and I put point, oh shoot. Y'all have to take me with a grain of salt right now because I'm kind of irritated at my son, so I'm irritated. Point, let's say 6.5. 0.65 people are crazy. Okay?
Mm-hmm.
If 0.5 people are crazy, what's the opposite of crazy?
0.35.
I mean, what's the opposite of the word crazy?
Oh.
Not crazy. So 0.35. Okay? I thought I went over all this.
How did you get 35?
Okay?
How did you get 0.35?
Okay? Let me go over that again. 60%. What does percent mean?
Part of one.
It means over what? Over 100.
Minus
So what is 60? If you got 60%, what's the total?
100.
All right. Somebody tell me what place value this is.
100th.
That's the 100th place value. So if that's 0.65, you're taking it away from 1 or 100. What's 65%? What would be the opposite? 35. Okay? So here you have words. Okay? Here you have a quantity. Here, these two right here, you're taking it away from either 100 because it's percent or 1 because it's a decimal. Those are the only three complements that you're going to have. So either you're going to say the opposite here. The opposite of white is black. The opposite of, I don't know, I can't think of one right now. Okay? Here, the quantity. Both the numbers are going to equal what? The total. Here, both the numbers are going to equal what? 100. And here, both the numbers are going to equal what? 1.
1.
That's it. You don't have any other, there's no other examples of complement. So if I give you 0.62, if this God blessed thing would write, 0.62, had to write like back in the day in second grade. If I give you 0.62, what's the complement?
0.38.
0.38. How did you know it's 0.38? Because this is a decimal. A decimal, the total is equal to what? 1. Okay, what if I give you 300 out of 500? Then what's the complement of 300? 200, because 300 plus 200 is equal to what? 500. If I give you 38%, then you know the complement of 38% is 60 what? 62%, because both of these equal to what? 100%. That's what percent means. So if you're given a decimal, the total is going to be 1. If you're given a percent, the total is going to be 100. If you're given a quantity, then you have to know what the quantity, the total is before the question. The question has to give you the total. So this has to be given with this. So this is the only one that isn't an assumption. This is an assumption. This is an assumption given by this. That tells you, okay, the total is going to equal to 1. This tells you the total is going to equal to what? 100. And then, of course, this has to be given. The total has to be given here because you don't know what it is. So with that last question, and you can use percentages too. Percent, let's do the percent. 6 over 10. Well, anytime you have something on the bottom, that's the total. Okay? So if I got 6 out of 10, then that means the complement is going to be what? 4 out of 10, because this is the total. Now if you change that to 0.6, then you're back to the decimal right here. And the opposite of 0.6, the complement of 0.6 is 0.4. Does that help with the complement?
Yes.
Okay? All right. Now, today I was going to go over the lottery. And before I go over the lottery, let me pull up the... Now, we covered permutations, right?
Yes, sir.
Okay.
Yes.
So let's pull up the lottery. Huh?
We cover combinations too.
We covered, yeah, but we didn't cover, we stopped at the lottery, I think, because I didn't want to
Yeah.
start. So I'm going to go to handy dandy South Carolina lottery. Let's see, it's called South Carolina Education, I don't know how to spell education, lottery.
Oh,
There we go. All right, and I'm going to pull up the Powerball. And I'm going to pull up how to play, and y'all need to copy that sentence, number one, not the whole thing, just part of it. Hold on a second. Let me blow it up so y'all can see it. Okay, there it is. That one right there. Write that down because this is going to be like a question. This is how the question is worded, except make heavy vertical marks. It ain't going to say that. So you don't have to write the heavy vertical marks. You don't have to write that. Just the select 5 different numbers, white balls from blah, 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 blah. So just write that. Now, let me go ahead and explain this, and I explain it on the videos also. And it's very important because some books are terrible with these questions, okay? What is the rule about the lottery? You can't win if you don't what?
Play.
Play. What does that mean? That there's no way you're going to win $100 million if you don't buy a dollar ticket. Now, what does that have to do with y'all? Well, on some of these questions, the questions are not worded correctly, and especially in this book, because this book sucks, okay? So what I tell students, I'm very lenient when the directions do not explain, okay? But I'm not lenient if the question does explain. Does everybody get that?
Yes.
All right. Now some of them are very vague, and some of them will say, "What is the probability?" Probability of what? Okay. So they don't even say the probability of winning. They just say, "What is the probability?" And then some say, "What is the probability of what? Winning." Now, when they say winning, they are assuming that you bought a what? And write that down. They are assuming you bought at least one what? At least one ticket. Now, what does this do to your problem? This makes it a 1 over the probability problem. Okay? And that's the important part. If they just ask what is the probability, they're not really telling you what they want. Okay? So there are some questions that and this is not good, okay? This is not good. That's the one that I'm saying is very vague. Does everybody understand that? Vague. Vague means that it doesn't tell you what it wants. What is the probability? That one's okay of winning. As long as it has the word winning or that W there, they're assuming that you bought at least one ticket. So therefore, your probability will be 1 over the probability. Now make sure you highlight this right here. Okay, because I don't want to go over it again. Assuming you bought at least one ticket, then that 1 will be over the probability. And then the third thing they'll say is what is the probability of winning? And I'm just going to write quotation marks, quotation marks, quotation marks with 15 tickets. In other words, you buy 15 tickets or whatever. And that's going to be 15 over the probability, okay? And we'll get to that in just a minute. You don't have to worry about that. I'm just showing you that you have to read the lottery questions very what? Very carefully. And this is the one I'm very lenient with. I'm very lenient with that one because it's not a good question. So if it pops up on your test or on the homework and you don't want to do it again, what I tell students to do on the homework, if you put 1 over the probability and marks it wrong, then they just want the denominator. Just do it again and type in the denominator, or vice versa. If they just want the denominator and you type in blah, 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 just do it over, okay? But if you don't want to do that, then see me and I'll give you credit for it. But on the test, I will give you credit for it because it is a vague question, and I try not to put those on the test. But sometimes they slip in through the algorithmic program. Sometimes they slip in. Okay, so with that being said, you wrote this problem down. Let's go to the whiteboard. And I'm going to show you how to set this problem up. 1 over 69, combination 5, times 26, combination 1. And that's how you set up the lottery. So go ahead and take your calculators and work on that. Okay, so we take our, I'm gonna go over to my Excel spreadsheet. I'm gonna show you a trick I learned in the war. Now, the reason I'm showing you the Excel spreadsheet is because you can do it in the Excel spreadsheet, and I'm also going to show you something else. And this is for you to, the real application. So let me draw it up to about 20 and take this out to about right there. There we go. All right. The first one, you can use the Excel spreadsheet to do combinations and permutations. I'll show you right quick. To use permutations, you type in equals permute, P-E-R-M-U-T. You see it right there in the blue? Click on it, or type parentheses, and I'm just going to do 20, 5. So y'all do 20, 5 in your calculator with a permutation. This is not to do with the problem. I'm just doing it to show you the word is permute, equals permute. And this is how you do a permutation on Excel. So on your calculator, you would type in 20, math, probability, permutation, 5 equals. Did y'all get 1,860,480?
Yes.
Okay. So that's how you do it on the Excel spreadsheet. So now I'm going to do a combination. Where's that coming from? I guess it's coming from. Is that coming from here or some? I think that's coming from here, isn't it?
It's not coming from here.
Okay. But y'all hear it?
Yeah.
Okay, somebody on the other side of the wall. It must be a big rat. All right, so equals combin, C-O-M-B-I-N. That's combination. Parentheses. And what did y'all do? 69, comma, what? 5. And enter. That's what y'all get? And I know what 26 combination of 1 is 26. So anytime you do a combination of 1, it's going to be n. Write that down if you need to. So 26, so equals combin, parentheses, 26, combination of 1, and that should equal 26. All right, so there's your denominator. We'll multiply them together. But I'm going to go down here, and I'm going to say 1 ticket, 10 tickets, 100 tickets, 1,000 tickets, 5,000 tickets, 10,000 tickets, 100,000 tickets, 1 million tickets, 2 million tickets. And let's go ahead and throw 5 million in there. Y'all with me? All right, let's see what happens when you do all that. So that's equal to 1, take this number, divide by, parentheses, this number, F4, times this number, F4, close parentheses. And I'm going to take it out to 15 digits. You don't have to do that, but I'm just doing it just to show you something. So right click, format cells, number. I'm going to take it out to 15 digits. And then I'm going to copy that down. I'm going to try to copy it down. So, now right quick, the number that you should get for your denominator is equal to this times this. So check your denominator, and that should be your denominator. Okay? But that's the decimal. This is the decimal. Now, if this don't make sense to you, let's do this. Change it to a percent. That usually makes a lot of sense to people. So let me ask you one question. Who is smarter? One person that buys one ticket or the person that buys 1,000,000 tickets?
No.
Look at the percentage.
Oh, no, it's neither.
The percentage is the same. So who's smarter, buying one ticket or buying 1,000,000 tickets?
One ticket, because he can waste a lot of money.
Exactly. That's the whole point. Okay? The person that buys one ticket is a whole lot smarter than the person that buys 1,000,000, because 1,000,000 is just wasting their what? Money. Now a lot of people say, well, Hubert, it's a better chance. That's a 0.003% chance. Do you know how small 0.003% is? It's about the width of a pen, okay? It's very, very, very small. So that's a little trick that you need to remember. So when you do buy a lottery ticket, should you buy 1, 10, or 1,000,000?
1.
Just 1. Okay? All right. Now, I'm going to show you one more thing. I got 4 minutes for those of you going to hysterics. Okay? Look at that number. 292,201,338. Everybody got that? Let's go back to the handy dandy. Go up here to odds. Oh my gosh, look at there. Y'all are as smart as those people in Columbia. That's not saying much. 292,201,338 people in Columbia are stupid. All right? So, what do you think about that? You got a better chance of getting hit by lightning or getting run over by a bus when you go outside.
Or about less.
Okay? So, but you don't play the lottery thinking you're going to win. You play the lottery for what? Fun, not hope. You can't put everything on the lottery ticket. You play it for fun, just like you play a raffle for fun. You don't put your whole paycheck in lottery tickets, because I just proved to you that it's not worth it, because you're not going to win. I mean, with 1,000,000 versus one ticket. Okay, who's got questions? Guess what?
We're done.
We're done with Unit 2. So that means, what next week? Homework questions, review, and what?
Test.
Make sure this weekend, when is the best time for you to do homework and get questions in?
Now.
This weekend.
Good.
Y'all have a good day, and I'll see y'all Monday.
No, I was in the bathroom when y'all